Hello everyone, I'm Paul and today we're solving problem 717, 1-bit and 2-bit characters. This is easy and the key to solve this is observation. So let's start. We are given a binary array bits with two types of special characters. For the first type we have a character that can be represented by number 0, and for the second type the character can be represented by either 10 or 11. So if we are given this binary array, here we have a character of type 2 and here we have a character of type 1. Our job is here, we need to return true if the last character is a 1-bit character, meaning a character of type 1. And here this is a type 1 character, so we return true. Now, if we are given this array, for example, here we have one character of type 2, and here we have another character of type 2. And given that the last character is not a 1-bit character, meaning it's not type 1, we return false. Now, I told you that this is all about observation, and here is why. Let's say that we are iterating this from left to right from index 0. So first we have a 1. And what this means is that this element must belong to type number 2. Why? Well, because type number 2 starts with 1 always, and type number 1 starts with 0. So whenever we find a 1, we know that the current element plus the next element will belong to the same character. Now, it doesn't matter if this is a 0 or if it's a 1. We only care about the length of the current character. We know that this has a length of 2. So at this point, we can skip this index and move to this index. Remember that we are iterating this from left to right. So now the I pointer is here. Now we have a 0, and what this means is that this element must belong to type number 1. Why? Well, because type number 1 starts with 0 and type number 2 starts with 1. So we know for sure that this belongs to type number 1. And given that we are standing on the last index and this is a 1-bit character, meaning it's type 1, we can return true. Let's do one more example just to make this clear. We are iterating this from left to right, so first the I pointer is here at index 0. We have a 1, this means that this element belongs to character number 2. And this means that we need to move the I pointer 2 spaces. We don't care about what's next. We only care about the length of the current character. Okay? So at this point we move the I pointer here. Next we are here, we have another 1. So this element belongs to character number 2. And character number 2 always has a length of 2. So this is the current character. This means that we can move the I pointer 2 spaces. Now the I pointer is here, we are out of bounds. And given that we have just skipped this last index, this means that the last character has 2 numbers. And at this point we can return false. So we can reduce this to the following. If we iterate the last index, this means that the last character has only 1 number. And if we don't iterate this index, if we skip this index, this means that the last character has 2 numbers. So here we return false. And by doing this, we are solving the problem in big O of n time complexity and big O of 1 space complexity. So with this in mind, let's go with the code. First, n is the length of bits. The I pointer is initially at 0, and we can say while I is smaller than n minus 1, if bits I, the current number, is 0, we move the I pointer 1 step. Else, meaning if it's 1, we know that we have a character of type 2, so we need to move the I pointer 2 steps. And finally, return I is equal to n minus 1, meaning if the I pointer is at the last index, we return true. Why? Well, because the last character in this case has 1 bit, else we return false. So this is the entire code. Now let's submit this. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.